Hello everyone. Today we're going to learn about formula units of ionic compounds and write formulas for ionic compounds and name ionic compounds and oxyions. Terms to review are nonmetals and nonmetals are sorry nonmetals are gases and they're dull, brittle, and they do not conduct electricity or heat. Okay, these are the terms we're going to go over. Okay, when we're writing the names and formulas for ionic compounds, always the cation is first, followed by the anion. And in the past, we know that cations is a positive, usually a metal, and ion is usually the nonmetal, which is negative. So this one would be barium sulfide, and barium is always the positive, sulfur is a negative. And then they have a system. Scientists have a system in naming compounds. So they always know that the metal goes first, the nonmetal is second. Positive first, negative second.
Formula unit. The simplest ratio of ions represented in an ionic compound.
Okay, so if we have barium sulfide, for example, barium is positive 2, sulfur is negative 2. We do the crisscross, it's 2 and 2. Formula unit is the simplest, so we have to simplify. So it'll be just cancel out or divide both by 2. So it's a B, A, and S, 1 and 1 ratio. Simplest ratio number.
Monatomic ion. An ion formed from only one atom.
Okay, so any of the metals or non-metals, just one atom, they lose and gain electrons and have a charge on them.
Oxidation number. The positive or negative charge of a monatomic ion.
Okay, so these are the elements in group 1. They lose 1, become positive. These are the elements in group 7. They gain 1, they become negative. And that charge is the oxidation number. So, like we said, cation is always first. Another thing to remember is the subscript represent the number of atoms. So if we have magnesium chloride and we do the crisscross, that subscript right here tells us that there are 2 chlorines for every 1 magnesium. And the total charge has to be 0. So it cannot be magnesium plus 2 and chlorine negative 1. It has to be equal to 0. So it takes 2 chlorines for every magnesium because the overall charge will cancel out. Negative 2, positive 2 will cancel out, and the overall will be 0. So the subscript tells us the number of elements, and the total charge is 0.
Polyatomic ion. An ion made up of 2 or more atoms bonded together that acts as a single unit with a net charge.
Okay, think of it as a basketball team. They all work together as a team, but the overall could be positive or negative. They work well together, they can win and have a positive impact or negative impact. So polyatomic, they're groups together with an overall charge. The subscript for a polyatomic can never be changed. So if it's NH4, you can never change that 4. Okay, if we have to do the crisscross, we have to put parentheses and then put the 2 or 3 outside if we have to. So the subscript goes outside the parentheses. But that 4, you cannot just multiply by 2 and put an 8 there. That will be correct formula. Okay, so you see the parentheses. Okay, this is a polyatomic table that you have to be a little bit familiar with. So, like ammonium, for example, it's NH4 plus. Nitrate, nitrite. One of them has one extra oxygen. The ATE has one extra oxygen. And hydroxide, you just have to remember. Acetate, you have to remember the way it is.
Oxyanion. A polyatomic ion composed of an element, usually a nonmetal, bonded to one or more oxygen atoms.
So it's a nonmetal with oxygen atoms. For example, NH3 and NH3 is, I'm sorry, NO3. NO3 negative is nitrate. One less oxygen is nitrite. SO4 negative 2 is sulfate. One less oxygen is sulfite. So you have to pay attention to the ending, and it tells you if it's less or more numbers. So you go to chlorate, but then if it's one more oxygen than the chlorate, then it's called perchlorate. And if it's one oxygen less than the chlorite, then it's hypochlorite. Okay, it's just a couple of things you have to pay attention to when you're looking at the polyatomic table. All right, so we've learned that the cation goes first, then the anion, and then the monoatomic cation, you put the name as is, and then for the anion, you put the root element, the root of the name, and then IDE is added to it. Okay. If it's a polyatomic and we do the crisscross, you don't change the subscript, you put parentheses. Let's see. And the polyatomic is always follows the cation. So you have here a kind of a table. First you determine the cations and the anions. So if we look on this side, we have iron and oxygen. So iron is the cations, oxygen is the anion. In this case, sodium is the cation, the polyphosphate is the anion. Now, when we look at this, iron is transition, so it takes a Roman numeral number. It takes 3. You can undo the crisscross, so that you get the Roman numeral from here, from the oxygen. So iron 3 oxide, and in this case, phosphate has a negative 3, so it takes 3 sodiums for every 1 phosphate. Okay, I'm gonna release another video, but it will go over naming. It will go over all these exercises for naming ionic compound. Okay, we'll see you next video.